Hello, today we're going to go over scientific notation. That's section 8.3 in your book on page 425. What is scientific notation? It's just another way. It is just another way to write a number. Okay, you write the number in the following format. A times 10 to the nth power, where A has a special name called the factor, and it must be between 1 and 10. It can be 1, notice the equal sign under the less than, but it cannot be 10. So it can be from 1.000 all the way up to 9.9999 forever, but it can't be 10. And then the other rule is that the n, the power of 10, must be an integer. Okay, you're used to seeing numbers in what's called standard form. Standard form is a number like you're used to, the number 5, number negative 2027, any number, any large number, small number, negative, positive, that's called standard form. So when we talk about scientific notation, why do you use them? Well, scientific notation is very handy when you have a very large number and your n value gets very big and you don't want to write out a big, long number, or your power is very small, a negative number, and the whole number is very small, and you don't want to write all the .00000, all the zeros to make it out. So standard notation or scientific notation works better for really large numbers and really big or really small numbers. So let's take a look. Since I have two ways of writing a number, there's two ways to translate. I can take my scientific notation number and translate it to standard, or I can do the opposite. I can take standard and translate it to scientific notation. Alright, so we're going to talk about both those things. Let's talk about the first one. Let's talk about scientific notation translated to standard. Okay, we'll talk about the other one next. All right, first of all, what are the rules for scientific notation? Okay, the first thing you want to do is look at the power. And the power from up above is the n value. So I'll write that in here, n. Okay, and you want to notice one thing. Is it greater than 0? Or less than 0? And once you know that, you can follow these following rules. If the power, or n, is greater than 0, in other words, it's a positive power, then you're going to move the decimal right n places. If your n value is less than 0, in other words, it's a negative power, then move the decimal left n places. Okay. When you're all said and done with that, then you got to make the number look like a real number. You have to add any zeros that you might need. Add any commas. And the decimal point itself. And you add them as you need them. And then you would have a standard number. You would have started with a number in scientific notation form, follow these rules, and you'll end up in a number in standard form. Okay, so let's take an example of that. Let's say I'm given the scientific notation number 2.45 times 10 to the 8th. Now that's a scientific notation number. Okay, 2.45 is my factor, or my A value from up above, A, times 10 to the 8th. 8th power, N is 8. Okay, so I can make a note of that. N is 8. All right, and I notice that that's positive. So I come up and look at my rules. If N is greater than 0, or a positive number, I'm going to move the decimal right N places. So I'm going to write my number again, 2.45. And how do I move the decimal right? I use the little bubble chart. 1, 2, 3, 4, 5, 6, 7, 8. Now I moved it over 8 places, so I know the decimal point goes right there. And then I am to fill in all the spots with zeros. And now I'll rewrite that, and I know that there's commas right there and there. So I'll rewrite that as 2, 4, 5, comma, 0, 0, 0, comma, 0, 0, 0. And that is my number in standard form for 2.45 times 10 to the 8th. Now let's try another number. Let's try number 3 times 10 to the negative 5. Okay, and in this example, I have a negative exponent, or a negative power here. So I write that here. I have N is equal to negative 5, which I know is negative, obviously. And I come up and I look at my answers here. I look at my rules, and my rules say that decimal must be moved to the left. So I write my number, and I know I'm going left, so I wrote it over to the side a little bit. 5 places. 5 places. 1, 2, 3, 4, 5. I know my new decimal spot goes right there. I fill in my spots as needed with zeros, and my new number is 0.00003. And that is the standard form of this scientific number. All right, let's see about the opposite of that. What if I want to go from standard to scientific notation? All right, if I want to do that, these are the rules I follow. Number 1, move the decimal. Okay, move the decimal point so it is just right of the first non-zero number. Okay, the resulting number is our factor, or our A value from up above. Come back up and look at this. When we do that first movement, we'll get our A value, or our factor. Okay? Then the second rule is count how far you moved. The number of decimal places moved. Decimal places moved, and your direction, left to right. Direction, left to right. Okay? Then you follow the final rules. If I moved left, then n is positive. If I moved right, n is negative. All right, so let's go to a new piece of paper here and try an example of that. We'll leave the rules right up there. All right, let's say our number is a large number. Let's try 30,500,000. Now that's a large number. We want to write it in scientific notation. So we're going to follow our rules, standard number, and we're going to write it in scientific notation. For the first rule is move the decimal point so it is just right at the first non-zero number. Well, the first non-zero number is this 3, right there. And here's where my decimal point starts. So I'm going to be moving this way. So if I'm coming this way, that's to the left. So I'm going to write that down right now. I'm moving to the left. And I'm going to count it. 1, 2, 3, 4, 5, 6, 7 places. So I went left 7. So I've now counted my decimal places and moved it in the right, and what direction I've moved. Left 7. Now I'm going to say if I moved left, then n is a positive number. So my resulting number with my new decimal place is 3.05 times 10. Well, my power is, since I moved left, my power is positive 10 to the 7th. So that is the scientific notation number for 30,500,000. Let's try another one. Let's try a small number. Let's try this number, 0.00078. Well, the first thing I want to do is find the first non-zero digit. There it is. Now I'm going to count my decimal places. 1, 2, 3, 4. I moved right 4. So I write my new factor, or my new A value is 7.8 times 10, and I moved right, which means my rule here says if right, then n is negative. Negative 4, and that is the scientific notation of that number right there. All right, that was example 1 and 2 in your book. Let's look at example 3, a little bit of use of scientific notation in the real world. You look at the chart. The chart shows you that you have $120 million in candy, 300 million in chocolate, and 1.45 billion in all candy sales. And they want you to write that in standard form and then in scientific notation. So let's take a look at candy first. Candy canes. That's 120 million. There's the standard form of that. Now let's look at chocolate. That's 300 million. Sorry, had that off the board. Let's go over that again. Candy canes were 120 million. Chocolates are 300 million. Now, what's all candy? Well, that was $1,450,000,000. Now, if we want to write those in scientific notation, what we have to do, if we remember our rules, is we're going to put the decimal place and under the first, this is standard, so under the first non-zero digit, so I find all three of my first non-zero digits. Then I'm going to count from my starting decimal point. Each of them is going left, so they're all going to go left. 1, 2, 3, 4, 5, 6, 7, 8. So this guy is left 8. This guy, 1, 2, 3, 4, 5, 6, 7, 8. He's also left 8. And this last guy, 1, 2, 3, 4, 5, 6, 7, 8, 9. He's left 9. Okay, so now my rules of writing this is my factor is where my new decimal place is. Still a dollar figure, so 1.2 times 10, and since I moved left, my power is positive to the 8th. This guy ends up being 3 times 10 to the 8th also, and the last guy becomes 1.45 times 10 to the 9th. Okay, and that's the answers to that guy, number 3. Now the last two parts about this is what happens if I have scientific notation and I want to do some math with that. I want to do some multiplication or division. Okay, well, let's take a look at multiplication first. Let's say I want to multiply two numbers together, and let's call the two numbers 5 times 10 to the negative 8th times 2.9 times 10 squared. Okay, so you can see I have two numbers in scientific notation format, and I want to multiply them together. Well, this is just like any other multiplication. I have four numbers. This number, the 10 with the power, the second factor, and the 2 to the 10 to the second power. So I can rewrite them because I can multiply in any order as 5 times 2.9. So I took the factor from both places, multiply them together, times 10 to the negative 8th times 10 to the squared. Okay, so I haven't done anything that you haven't seen before, but now I've got something pretty simple. I've got two numbers I can multiply together, simple numbers, and I've got two powers, or two bases with powers, and I know I can add those together. So 5 times 2.9 is 14.5, and then I'm going to add these two powers together. Negative 8 plus 2 gives me 14.5 times 10 to the negative 6, and then I can write that as I would like to write that as a scientific notation, but what's wrong with my factor here? My factor is bigger than 10. So I'm going to rewrite this as this part of it as a scientific notation. So I move my decimal. Here's my first significant digit there, so I know I'm going to have 1.45 times 10. And which way did I move my decimal? One way to the left. If I move left one, I make the power positive, 10 to the first. I'm still multiplying times 10 to the second, or 10 to the minus 6. Now I'm going to write those as three numbers. And I notice again I have a base 10 with a raised to a power. So I can use my rules of adding exponents, and I get 1.45 times 10 to the first plus a minus 6, and I finally end up with 1.45 times 10 to the minus 5. And that is the answer to that multiplication up above. If then somebody wanted to me to write that out as an actual number in standard form, I would take my 1.45 and I would move it 1, 2, 3, 4, 5 decimal places to the left, fill in as needed, and my final answer, if I wanted it in standard form, is 40145, and there is the number written in standard form. All right, let's try another example. Okay, let's do example of division. What if I had 1.2789 times 10 to the 9th power divided by 5.22 times 10 to the 5th power. Okay, well, in this example, you can see we're going to do a lot like we did here. We're going to rearrange the numbers. When we're multiplying, we rearranged them. We can do the same thing when we're dividing. We're going to take the two factors, 1.2789 divided by 5.22, and work with them by themselves. Then we're going to multiply that times the two powers, base 10 powers, and we can start to see what's going to happen. If you got your calculator out and divided this, you end up with 0.245. And over here, we remember from our rules is we can subtract exponents when we're dividing. So 9 minus 5, so we end up with 0.245 times 10 to the 4th. Okay, once again, we can't write that directly as scientific notation because this number, 0.245, is not greater than 1. So if it's going to be greater than 1, we want to rewrite this in its own scientific notation. We're going to move it there. And my new factor is 2.45 times 10 to the what? Well, I moved it to the right. Okay, so that's a -1 when I do that. Still times 10 to the 4th. So I'm going to rewrite that one more time. 2.45 times 10 to the -1 times 10 to the 4th. One more rewrite. 2.45 times 10 to the -1 plus 4, because I'm adding exponents now because they're multiplied times each other. And I end up with 2.45 times 10 to the 3rd. And if I wanted to express that in standard form, I take my 2.45, move it 3 spots, there's where it is, and my final answer is 2,450.